All right. Hello, everyone.
Yes.
Welcome to our episode two of Geeky podcast. And today we have a very special guest, Mr. Vishu Vishal. So Vishu is a dear friend and a very special friend because we actually started our professional journey together. And he's a very passionate power sector engineer. I know you must have like a fancy title, but I think you are one of the most passionate guys I've seen who's been like working in power sector for almost a decade. So, Vishu, why don't we start with your introduction?
Yeah. Hi, Shil, and many thanks for having me here in this show, and thanks to the Geeky podcast for this good initiative. So I have done BTech in mechanical engineering from KIIT University Bhubaneswar, and undergone my training at NPTI Nagpur also, and I joined Tata Power together with Shil, and that's how we are very well connected for over more than a decade.
Yeah.
And I worked in multiple streams in leading organizations such as Tata Power Distribution Limited, and currently I'm working with the company called Indian Energy Exchange, looking after strategy, working as a senior manager strategy. So it has been really a wonderful journey in power sector for more than a decade, and looking at almost the entire value chain of power sector is always a pleasure, and that too when the sector is undergoing huge transformation. And so excited to be part of this show, especially with my friend Shield, because we started our journey almost one decade ago, and it was really, really amazing the way we, used to hang out, the way we used to, do party and start our professional career.
Awesome.
Yeah.
Yeah, thank you so much, Vishu, for joining on this show. So basically, I'll just give you a quick idea about the format of the show. So what we are trying to do here is, we want to connect with different, experts from different fields, and at the core of everything, we want to keep the conversation very geeky. So I'll be asking you questions which might be, very basic for you, but I just want like all the viewers to understand the basics of power sector, and ultimately, this the show is more about like circling back to the AI revolution that we have. So I mean, about myself, right? Like, so I'm a AI professional. For those who don't know me, so I've been like working in AI for almost half a decade now, and I started up my career with Vishu Vishal in power sector. So it has been quite a journey for me as well. And I love doing research in the field of AI, and my goal here is to connect with different people from different sectors, and just want to understand like how AI is revolutionizing their fields as well. So like right today, we when we think of AI, right, we always think about some coder in a basement with a hoodie, doing some coding and doing some automation, but actually it's not that fancy. Generally, it's more about solving real life problems, and some real life problems, especially when we talk about power sector, right? We often ignore it because I remember when I started working in power sector, it was called as the invisible product because it's something that we cannot see. Power is like it's all it's around us all the time, and we don't even like acknowledge its importance because we have taken it for granted, but it's around us and it runs everything. Technology today runs on electricity, right? And electricity is being generated by different sources, renewable, non-renewable. All these things are going on, and not just that. Like, it's not just generated; it's being like transmitted, and so many things are going on behind the scenes. And what is the role of AI in that? So we'll go into all of that, but before we deep dive into those aspects, I just want like Vishu, uh, can you like explain like for our viewers who are not aware of like this sector, the power sector, right? Professionally, like what is it like, and what is the most exciting part about it?
Yeah, Sheil, that's a very interesting question because when you talk about the most exciting part, so for me everything is exciting in this today's context. Let me connect it with the overall climate objective because that would give a sense why this sector is now very exciting. So as we all know that we are facing a huge challenge in terms of climate change, and every country in the world is almost part of Paris Climate Agreement, wherein we have to ensure that the Earth's temperature has to be maintained and restrained at 1.5 degrees by the end of this century. And according to recent report of United Nations emission gap, we already we need to reduce GHG emission at a global level by 45% from current level till 2030 to remain on 1.5 degrees pathways. So that's the overall objective that everyone in the world has to work upon. And why I'm relating it with climate is because power sector accounts for more than 35% of energy related emissions, and energy sector as a whole is responsible for almost 70% of total man-made GHG emissions that we cause in the atmosphere. So it's very important that if we have to ensure our existence and ensure survival of the earth, then energy sector is very important role, very important element to work upon. And within energy as well, power sector is again a very important element. So the entire journey of power sector, the entire transformation is I can say that it is driven by 4 Ds. So first D is obviously decarbonization, which talks about how you can decarbonize power generation, power transmission, and power consumption as well. So entire decarbonization as aspect that we need to work upon. The second D talks about digitalization. So rightly so, the theme that we are discussing today is use of technology in the power sector, and therefore this important element we'll talk about in detail is about how digitalization can support decarbonization and using access and providing access of electricity to every consumer in the world. The third important element is decentralization. So, you and I come from the era where we used to work for setting a large thermal stations or a large hydro stations located at one place, and that used to transmit power to consumers located at different places or maybe different locations. But now we are coming to an era where each location itself will be acting as a powerhouse in terms of decentralization of the generating units. So smaller generating units will be set up at different locations, which will be catering to some part of the energy requirement of the consumer at that level itself. The fourth element is is about how you can support the empowerment of consumer, that we call it as democratization. So it is empowering the consumers that they can act as a prosumer, wherein they can generate power, they can consume power, they can install stations, and they can participate in the power sector or power system functioning by various means, which I'll talk about later. So, to sum it up, the entire power sector or entire energy sector is going through a massive transformation from a traditional fossil fuel based generating systems to a cleaner system, and that cleaner system is also driven by decentralization, wherein the units are located at the point of consumption itself. And there are a lot of tech based solutions, tech based enablers I would call it, would be required to facilitate this transition towards a non-fossil or a cleaner power system. And that would require a lot of interventions, which already we are seeing across the world. So as we go along, we will talk about what are those tech based interventions that would be required. But to answer your question, this transition is very exciting. In fact, for last 10 years, if you see overall in the world, if I say for India, one decade, a decade ago, the fossil fuel contribution in terms of generation was more than 80%, 90% in the power system. Today the fossil fuel in terms of installed capacity has come down to 60 or 58%. So 42, 43% of installed capacity mix that we have in India is served by a non-fossil generating unit. Similarly, across the world, if you see in China or in US market, in Europe, and in Australia, everywhere you would see that there is a massive addition of renewable energy capacity. and that is driven by, of course, the scalability of technologies of clean sources, and a strong mandate to work towards climate change and make the system clean.
Awesome. That's that's a really good explanation, Vishu. I have one follow up question, especially for the young viewers who are listening it about the power sector, are not very much aware of it. So when you said like there is a Paris Accord, right? Like, and there's like a constraint of the temperature. I think 1 point something degrees that you mentioned. So why do you think
Yes.
there is a like a concern with respect to power sector? Can you explain like how is power sector impacting? I know you talked about renewable and non-renewable, but just explain like how renewable versus renewable ratio impacts the climate of our planet.
Perfect. And that's a very important question, Shil, because as a consumer, we have to be demanding in terms of what kind of energy we consume. So it is very important for every consumer to be aware about how the energy is produced, how it leads to climate change, and therefore the consumer sensitization and consumers pressure is also very important to ensure that the decarbonization of power sector is done in an expeditious manner, and also to act as a pressure to these fossil fuel based generating stations to decarbonize. So how it happens is basically, currently most of the energy that we consume is coming from thermal power plant stations. So for viewers who are not from the power sector, so let me simplify. Normally in thermal power sectors, thermal power generating stations, we use coal and we burn the coal to create steam, and that steam, high pressure steam, turns the turbine, and therefore we generate electricity. And whatever coal we burn, that goes into the atmosphere in terms of carbon dioxide, in terms of sulfur dioxide, other nitrogen dioxide and monoxide. So various kinds of GHG gases are getting emitted by virtue of generating electricity. And just to give you a number, in most of the thermal stations, almost for every unit of electricity we generate, almost 900 grams or 800 grams, depending upon each country, of CO2 is emitted into the atmosphere. That's called grid intensity factor. So in India it's almost 0.92, so which means that for every unit being generated, 920 gram of CO2 is coming into the atmosphere. Now we all know that these
What is 1 unit of power that you're saying?
so 1 unit of electricity means 1 kilowatt hour. So 1 kilowatt of hour of electricity that we consume is normally called as 1 unit of electricity, and that's how every consumer is built. So for every 1 unit of electricity that is generated, almost 900 or 800 grams of CO2 comes into the atmosphere.
Wow, that's
So it,
a lot,
yeah.
right?
Yeah,
Yeah.
it's a lot. It's a lot. Yes, yes. So that's why, Sheil, it's a very relevant question, and it's very important for everyone to understand that every energy that we are consuming, especially in terms of electricity, and of course, transportation is also mostly fossil based right now. So every unit of electricity that we are consuming is probably, majority of them is are coming from coal, in many developed economies, and therefore uh, we need to transition the way we generate electricity, right? So we need to find other solutions which does not burn coal, which does not use fossil fuel for generating electricity, and therefore we are observing that there is a huge push towards using more and more solar capacities, using more and more wind capacities, using more and more hydro, and all those clean sources of energy that we can harness, so that we do not pollute the environment in terms of our own energy requirement. And since we need to reduce CO2 emission into the atmosphere, as I said, uh, we are in a very alarming state, Shil. Although it sounds bit, scary, but it's true. It's all based on science, right? So we need to reduce GHG emission at a global level uh, by 45%. So currently we are almost emitting almost 52 gigatons at a global level. That must come down to 30-35 gigatons by 2030. So although every country, every economy is growing and we are increasing our energy requirement the way we are doing development, but on a contrary, the challenge is how we can reduce CO2 emission at a global level. And therefore, as I mentioned in the introduction itself, that energy consumption related emission is almost 70% of the total man-made emission that we do right now, right? And within energy, power sector is almost 30-35% of is contributing for GHG emission. So therefore, it is very important that we decarbonize, we change the way we produce energy, and we move towards cleaner and greener sources of energy production.
So, what is the biggest hurdle here? Like, why don't just everyone switch to renewable rather than using these fossil fuels?
So that's again a very interesting question, and the most important challenge that we face as a power engineer or a power professional is that we have to understand how power sector works. Unlike any other sector, for example, using a fossil car or using a petrol or diesel driven car can be replaced with a, let's say, biofuel or CNG based vehicle very easily without much of an issue. The only thing that you need is the availability of CNG or a biofuel, right? But power sector is, the way it works. The entire grid, entire transmission and distribution network is integrated, and the system needs to be balanced in such a way that demand and supply has to always match, and you have to ensure that the grid frequency should be maintained at the defined level. For example, in case of India, it is 50 hertz. So 50 hertz plus minus some delta, very small band is something that the grid operator has to manage. In case of US, it's 60 hertz. In case of Japan, I think also it's 60 hertz. So whatever frequency band the system operator designs, you have to maintain that frequency. And therefore, the most important challenge in transitioning towards renewable is that renewable generation is highly unpredictable, right? The way we produce electricity in coal based thermal station, you have control over how much power you want to produce. You can simply throttle the coal flow in the coal mill of a thermal power plant, and you can decrease the generation or power generation, or you can increase the coal input and increase the generation. So it's all controllable, right? It's a controllable form of generation. Similarly, if you talk about hydro power stations, you again have sluice gate wherein you can control the flow of water into the turbine, and you can regulate the power generation from a hydro power plant. Gas also works in a similar manner. But when we talk about renewable power plants, especially solar and wind, these are all totally weather dependent. So it will depend upon what amount of sunshine is there, whether the weather is cloudy or not, what amount of wind is flowing. If it's too high, again, it cannot generate power. If it's too low, again, it will impact. So there is a requirement of an optimum wind speed for you to get power generation. There is a requirement of a decent sunshine and availability of good location to produce solar power. All these are beyond control of human beings. It's all about nature, right? So therefore, we don't have absolute visibility on what would be the generation, but we have to ensure that the generation is always matching the load that we have. Traditionally, Sheel, what has been happening is that when you switch off your TV, or when you switch off any electronics that you are working, correspondingly, at the back end there is someone who is recording all these aggregated actions of load variation, and someone at the back end, that is a system operator, is controlling the generation of the generating unit, so that the system is maintained at 50 hertz. It's all about electrical stuffs, right? But in case of renewable, the challenge is we don't know how the generation would be. We do have some, that's where we will talk about AI and forecasting and all those activities. We do have some visibility in terms of what would be the generation, but again, it's not foolproof, right? But at the same time, you have a challenge that whenever there is load variation or if it is raining, or if there's party, if there's some festival, whatever, that needs to be balanced with a generation, with a generation which is variable in nature, which is beyond my control, right? So there has to be other tech based interventions which will give me a tool to manage my load generation and match the variable, demand pattern that may have, so that the system frequency is maintained at 50 hertz. So therefore, what is happening around the world, if you see that there's a huge focus on battery storage systems, whether you talk about battery storage system, whether you talk about pump hydro storage system. So anything that can store energy. We all know that we use cells or batteries in different devices, in laptops, in watches, everywhere we use cells and batteries, right? And they store energy in form of chemical energy, and when we discharge again, electrical energy is produced. So the challenge that every power system across the world is facing right now is how we can add more and more renewable energy, and appreciating the fact that these renewable energies are totally unpredictable in nature, how we can store it so that we create it and make it of a similar nature, the way we can control fossil fuel based or a hydro station based station, power plants, so that we can manage, we can match the demand and supply in a manner that the grid operations are not impacted.
Okay. So basically, you're trying to solve the non-reliability or unreliability of
Yes.
renewable
Yes.
sources by
Yes.
creating some kind of a storage solution where you can store the electricity whenever, and then we can use it whenever we don't have those renewable sources available, right? Because that's the biggest problem right now, and you very nicely explained it, right? Like in thermal, we can throw in the amount of coal we want, or reduce or increase it based on the requirement. But in solar, we cannot control it because solar depends on so many things, right? How much sunlight is available right now. It also depends from, 1 month to another, from one place to another, time of the day. Everything is is completely variable, right? So yeah, it definitely makes sense. So as of today, right, like we are in the era of our automobile sector turning into like an EV sector, right? Like there's so many EV vehicles coming in. If I buy an EV and if I charge, like my assumption is, like if I'm using an EV car versus a non-EV car, I'm assuming that I am doing good for the environment. Is it true, or behind the scenes, again, maybe the power is coming from a thermal power? I mean, how do you think about it? Like, do you think using more electric vehicles right now would be one of the solutions?
Again, that's a very interesting question and when very debatable. But let me, give you an answer that in the overall life cycle of EV vehicle versus a fossil vehicle, there is a difference of, almost 20-30% of GHG emission. But
What
if
is
you
what is GHG? Okay.
greenhouse gas, for example, CO2, methane, all those gases that cause global warming impact. So there is a difference. There is in fact quite a lot of difference in the total GHG emission that is produced by an EV vehicle versus a non-EV or a fossil-driven vehicle. But as you mentioned, it's a very relevant question that what is the nature of energy we are using to charge electric vehicle? That is very important. And see, Sheil, the most important aspect that we have to appreciate is that we are bound to clean the electricity grid, and it is happening every year. If you see the trend line of last 5 years, so India, if I take the example of India, because we are very, we are decarbonizing at a very faster rate, and so the world as a whole. So we have added more than 70-80 gigawatt of renewable capacity over last 5 years, and the target is to have a 500 gigawatt of non-fossil capacity by 2030. So the challenge is we have to add 50 gigawatt of RE capacity each year from 2023 to 27, 28, which means that the line and the site is absolutely clear that the grid is going to become cleaner and cleaner as we go ahead, right?
And
Today,
by
I agree with your point
cleaner, you
that
mean, by cleaner you mean power generated from renewable sources.
renewable sources. Yes, 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 yes. So simple. The matrix is called carbon intensity factor, or simply even called grid intensity factor. So if I talk about Indian power grid, what is the CO2 emission that power sector as a whole is causing to produce 1 unit of electricity? So as I told you, it's 0.92 at present, which means that for every kilowatt hour of electricity that Indian power system is producing, almost 920 grams of CO2 is coming into the atmosphere, right? So that 920 gram will keep on coming down. And for example, if I tell you in UK, this number is 250 gram. So UK power system is much cleaner because they depend upon hydro and gases and all other renewable sources, offshore wind. Similarly, for European system, it is around 0.52, which is 500 grams per kilowatt hour. So the trend line is very clear that globe as a whole is going to decarbonize power system in a very faster manner going forward. And therefore, whoever is using EV or intending to use EV should not have this question in mind that I'm actually not working much for the environment. But in the present context, because yes, I agree with your point that today the fossil fuel is still having a larger share in the total power that we consume, but that depends upon country to country. But going forward we will have a higher share of renewable energy, and therefore the energy input that you will be using to charge your electric vehicle will be a green source, and therefore you will be actually eliminating a lot of carbon emission into the atmosphere. So I would strongly recommend that whoever is willing to embrace or adopt electric vehicle must do, because that would be indeed helping the environment.
Okay, so I do have one question regarding that because we are already on the topic. So you must have heard about some load issues in California where there was a sudden increase in the number of EVs that are being used, and because an EV consumes a lot of electricity, and the grid is not designed to take that much amount of load, and now everyone in California is driving an EV, and suddenly the increase in load led to the blackouts that happened recently. So what do you think will happen if everybody starts using EV? Is it like, is the power sector today ready to accept that much amount of load? For I'll just give you an example. So I do drive an EV. So my total consumption of my a two-bedroom apartment right now is around I would say 400 to 500 kilowatt hour, and my car itself consumes around 400 to 600 kilowatt hours depending upon how much I use it. So that's like another two-bedroom apartment consumption, right? So technically, I'm consuming twice the amount of energy from electricity now because I'm already living in my apartment. My car is also consuming the same amount of energy. So it's like doubling the consumption, right? And just consider everyone starts using EV. Everyone is charging their cars in their homes, and suddenly there's a huge requirement of energy to support that much amount of load. Do you think like our sector, power sector right now, is ready to take that much amount of load, or how? What is the way forward?
Yeah, that's a very interesting question, Shil. And let me give you some statistics, because that will solve the lot of questions that you have in your mind. So, in case of India, and I'm giving you a much bigger example, right? California is just one area, but I'm giving you an example of entire country. If I talk to you about the 2030 number that have been projected by Central Electricity Authority and also by international energy agencies, they have come out with a number by 2030. The total peak load demand or total impact of demand because of EVs will be around, let's say somebody says 15 gigawatt, somebody says 25 gigawatt. So I'm giving you a number that it would be between 15, 20, or 25 gigawatt, right? the total peak demand will be impacted by this amount. And the total energy requirement in terms of billion units would be around 30 BUs, 35 BUs, right? That, and that, if you compare with the total energy requirement at a country level of 2030, would be hardly 2.5 percentage. That's it. So 2030, the total power requirement of India as a whole has been projected around 2258 billion units, and the total impact of electric vehicles at a country level would be just 35 BUs, or 2.5 percentage. So the reason why I'm giving you this number is to understand that what happened in California, it cannot be solely attributed to the electric vehicles. There are various factors because of which that happened. One, because of unprecedented rise in demand, and other because of the non-availability of sufficient transmission capacity to import electricity from other geographies of United States, US power market, and also because of some issues related to gas prices. So, it would be incorrect to single out EV and say that EV alone caused all this, because if you see the impact of EV in the total demand, that is very minuscule. It's not 2-3%, hardly 2-3%, with a good penetration, right? So that's point number one. That EV is not such a big problem that will cause havoc. But I do appreciate your point that in some areas, especially the apartments where a lot of EVs will be charged, the local distribution transformers need to be upgraded by giving due recognition to the charging time, which brings to another question, that how we can chase load with respect to the variable generation. Right now, Shil, what traditionally we have been doing, that the generation was chasing load, right? So based on load variation, I would increase or decrease coal in the thermal power plant, and I will vary my generation. Now, what you'll have to do, the load needs to chase generation, which means that when there is enough solar, you need to use more and more energy for your daily consumption, right? That we call in simple terms demand response, which means that in places like California, or in places where you have high solar capacity or high wind capacity, you need to create a mechanism or regulatory framework wherein people respond to the mechanisms called demand response. That is, you should get an indication that, look, between 12 p.m. and 2 p.m., the prices will be 30% discounted, and therefore you will be incentivized to charge your electric vehicles during that particular duration. You would be incentivized to use your washing machines and other appliances as much as possible, so that you are consuming the excess renewable energy that is getting generated in the grid, which otherwise would have to be curtailed because you cannot store electricity, right? So therefore it is very important that we provide these kind of demand response mechanisms, and the simple way of doing that is through time of the day tariff, which means that for evening hour the price of electricity would be higher, and for morning hours, when you have enough solar, the price of electricity will be cheaper. So you would be targeting to charge your electric vehicles during solar hours, in the morning hours, so that you are using cheaper electricity and you are using greener electricity, and you are solving the problem of the grid in terms of absorbing huge amount of renewable generation, which otherwise would be curtailed if it does not match with the load. So all the problems will get resolved with this kind of mechanism.
That is very interesting because I am a consumer of hourly pricing. So the distributor at my location, it's actually they're called as ComEd. So they have like some hourly pricing. So by default, you have a flat rate, and then you have to apply for an hourly pricing. So after buying an EV, because I wanted to optimize my spending on electricity consumption, I applied
Yes.
for an hourly pricing, and then they have like a chart. So on the app, I can just go and see like what are the different rates at different times, and I can basically schedule all my washing machine and dryers and dishwasher and my car charging in that slot, like technically to get the lowest amount of electricity bill, right? So I think maybe that's what you're saying, right? Like that's what is incentivizing the customer to use heavy load activities during a certain time period, and then leave reduce the load at other times, right? I think that's what
Yes,
incentivizing means.
yes, yes, yes.
Interesting. Yeah, I mean, this is very interesting, right? And I do observe, I did observe that you use terms like generation, transmission, and distribution. So for our viewers who are not very much aware of power sector, maybe you can just very quickly explain the business of power sector. How, what is power sector? If let's say a company, somebody wants to set up a company, what are the different components of power sector, and on a high level, right? Like, can you explain and also talk
Yeah,
about
yeah.
distribution, transmission, distribution?
Sure, 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 sure. So, see, traditionally, in a very simpler terms, power generation is happening at generating stations. So, the way we have seen traditionally, you would see a thermal power plant wherein, you may recognize through the chimneys, the tall chimneys that can be visible from a longer distance, or the cooling towers which are visible from a longer distance. So they have a system of boilers, turbines, coal handling plant which uses coal to turn steam, and then that turns turbine and which generates electricity. Now that electricity needs to be transmitted to the load centers, to the cities where the power will be consumed, right? So how do we do that? And we must appreciate the fact that when you transmit electricity, there is a loss of energy in terms of I square r losses, right? So what is being done, that when we are transmitting electricity from the power generating site to the load center, right? So we use high voltage transmission system. So when you increase the voltage, the current becomes low, and therefore the I square r losses are low, right? So that power then reaches to the distribution network, essentially the place where the load centers would be located, cities, for example, cities. So you would see that thermal power plants and other power generating stations, larger units, are located slightly far away from the cities where there huge amount of land, the coal is available, or some plant are even located nearby the seaports, for example, if they are consuming the imported coal. So plants will be located far away, and that energy, that electrical energy, it needs to be transmitted to the load center or the other cities, and that happens to a power transmission network, which are essentially of the order to 20 kilovolts and maybe upward of that. And that power reaches to a distribution system level, where a power distribution company, which is distributing power to retail level, for example, shield customers like you. So that company will be receiving that power from the transmission, high voltage transmission system, and they will be converting that electrical energy to a low voltage system, depending upon each consumer type requirement. And that power would be supplied to your homes. There would be proper metering in infrastructure, who which would be responsible for estimating how much you have consumed, and billing will be done. And the customers need to pay to the distribution licensee, and distribution licensee in turn will pay to the generating stations from which they have purchased electricity. The tariff of transmission and all those TNT networks are uh, recovered from the end consumer through distribution network. So this is how the system works in a broader way.
Okay, so you're saying that there are generating stations, and there are like transmission lines, and then there is a distribution. So generating stations are generally outside of the cities, and they generate power through maybe coal or solar or wind.
Hydro.
They
Hmm.
generate it, and then they send it across large distances. Maybe like we are
Yeah.
generating solar energy in Texas, and we are consuming it in Illinois. So those electricity basically are getting transmitted interstate, right? And then they come to my location where I am right now, and then there is a distribution company here which kind of takes that power, reduces it to a lower voltage, which is consumable for residential use cases, and then from there I have like meters where I can build. Okay, so
Yes.
that's a very interesting way of explaining it. So okay, I mean, till now it makes sense. So like again, this is the Geeky podcast. We're talking about lots of AI and stuff, right? And
Yeah.
we are right now in the AI revolution where everyone is, I think, aware of all the open source models or the chat GPTs of the world right now coming up, the large language models that have come up suddenly and taken the world by storm, right? Like, I'm sure everybody has been aware of these large language models. You have a chat GPT app for your iPhone. uh, you can just download it and ask questions, and it's like a bot which knows everything, right? So in this revolution where we have AI doing, becoming like a all knowledgeable chatbot, or it can do a lot of forecasting and do lots of automation. What do you think is the role of AI in power sector? Because whenever I think of power sector, I think of chimneys, or uh, you know thermal power plants, or maybe large wind turbines. When I drive off in the countryside, I see those, or rooftop solar panels, right? But I never think about it as a sector which can be driven by AI, right? So it might be my lack of knowledge. Maybe I'm being ignorant enough, but can you explain, like, how is AI already powering the power sector, or where are we with respect to usage of AI currently in power sector, and what are the different use cases?
That's a very interesting question, Sil. And since it's a very important question, I would take a moment to explain about the use cases. So yes, you are very correct. AI is already implemented in some form or the other in power systems. But what is more important to understand is the fact that why the role of AI and tech-based solutions, if I may use the broader term, tech-based solutions is going to go much beyond what is being deployed right now in the years to come, is because of the fact that we are transitioning the entire power system. We are moving from a controllable generation to a non-controllable generation. We are moving from a centralized generating stations to decentralized generation generating stations. We are moving from consumer based power system to a prosumer based power system. Prosumer means a consumer who can also generate power through rooftop solar, right? So the entire game of things is evolving, and it is evolving so fast that you need tech-based solutions to ensure that the fundamental requirement of operating a power grid, that is to maintain the frequency and voltage and other electrical limitations and parameters that we have to ensure, is controlled and is you know adhered to. So for that you need a lot of AI and tech based solutions. So I'll give you some examples. For example, and this people can easily relate. For example, you are using electric vehicle. Suppose you plan to install solar rooftop at your roof, and you want to become self sufficient to whatever extent you can, and you also you want to install a battery solar system, so that you generate yourself electrical energy through your solar rooftop. You charge your EV using that. If you don't need the energy at some point in time, you can store through battery storage system, and then again you can discharge and use in some other point of time. But this but again, if still you have some excess, you need to sell that to the grid, right? uh, but someone has to do the calculation, right? Someone has to do the estimation on a real time basis, that what is your consumption, what is your generation, what energy is being stored, and what you can sell to the grid and earn money. So we call it an optimization problem. Optimization in terms of producing energy yourself, consuming energy yourself, and making decision that if there is a higher price in the wholesale market or power exchanges, you can sell that electricity at a higher price and earn revenue. And therefore in that manner you can minimize your power bills, or you can use your internal power generating station or internal rooftop and battery to earn revenue and minimize your power consumption cost. So activity that I just explained requires a lot of AI ML based system and technologies in place, which will do estimation of what is the sunshine level and how much energy solar panel will be generating, what is the prices in the wholesale market or power exchanges is going to be. If the price is high or low, then the algorithm will decide that whether you should consume the energy yourself or you should sell in the wholesale market or the local energy market
Okay.
and earn money. So all these part, the decision making part, identification and decision making part is something that will be required at a consumer level, so that the not only the grid operation but also the economic manner or economic benefits of that particular decentralized model can be fully harnessed. So that's one example, and I can easily relate that with this solution being deployed in California, and this has been deployed by GE Electrical, General Electric, electrical grid electrical, some name I'm forgetting the exact name of that company, but it's a solution deployed by GE, and it's called DERMS, Distributed Energy Resources Management, wherein at a household level or at a society level, you can aggregate distributed energy, both solar rooftop and batteries, and you can trade the excess energy in the wholesale market or exchanges where the prices are higher, and in that manner you can make money out of the excess energy that you have in your house. At the same time, you can reduce your dependence on the grid, power grid, right? So therefore, the need for large scale building of interstate transmission networks, which is very capex intensive, will also reduce, right? And lesser dependence on central transmission will also ensure grid security, because just imagine, what if a big transmission network line goes for a fault, or there's some technical issue, the entire region is support could be prone to blackout, right? So the lesser dependence on central grid is more favorable for power system, because the local energy production will reduce the dependence on central grid. At the same time, it will empower consumer and it will help them to make green energy themselves and fulfill some part of their energy requirement in house. And also, if possible, they can use surplus energy to sell to your peers. We call it peer to peer trading, right? So suppose you have a neighbor who is requiring larger amount of energy, and you are going for a vacation, but you have solar rooftop installed at your house. What do you do with that energy? You can't let that energy go for a waste. So you can sell that energy to your neighbor who would be there, and if you're going on a vacation, that solar rooftop gives you revenue while you're not even at your home. So these kind of innovative models, like peer-to-peer technologies, local energy market, what we call, and these are already being deployed in places like Australia, in California, in Germany, in other parts of Europe where there is a good amount of solar rooftop penetration. So all these decision making activities, which will control these distributed energy resources in a manner that they meet the electrical constraints. At the same time, it creates a revenue maximization output for a prosumer, is something that is the need of the hour, and therefore here AIML will be of a great help. The other use case that I wanted to talk about is that, she look, our sector is highly dependent upon a lot of technical requirements, lot of regulatory and policy level changes that keeps on happening. There are so many amendments of regulations, orders that will happen every time. There are so many states, so many central regulator, state regulator, grid operator. So you mentioned about ChatGPT, right? So now, definitely, such solution would help power engineer or a power sector professional to use such solutions and get a very easily comprehensive document, which can help you that, look, if I am a large commercial and industrial consumer, and I want to meet my energy requirements through open access or through purchasing power from a third party renewable station, what are the regulatory policy and technical requirements I need to make or I need to comply with for a particular location. So today we are doing it on a manual basis, where some has to refer so and so regulation, some has to refer so and so state tariff order, some has to refer policies, and then there would be huge number of documents, and then you will find out each relevant point and make a document, right? That may take weeks for someone, but if there is a technology solutions like ChatGPT or similar to that, that can very easily go and collect those documents, find the relevant clauses, and just give you an output that, look, you need to follow this technical requirement, you need to follow this commercial requirement, this will be your cost, this will be the compliance requirement, and therefore in order to adopt this model, these are the 10 number of activities that you need to do, right? So that type of solution will make life easier for someone to make faster decision, deploy renewables or innovative models in a faster manner, and help the decarbonization and also meet the energy in a most cost competitive manner. Plus,
Okay.
uh, if I talk about the other areas that will help, for example, the use of tech based solutions, you must be aware that, I think you may recall that you yourself has worked in a solar power plant construction in Maharashtra, I believe, and there you would have seen that the locations are very remote, right? So it's very difficult for someone to clean the modules. There would be dust which gets deposited on the panels, right? So you need to clean the modules so that it actually generates the power that it has been designed, right? And the one way of doing that is manually spraying water or air pressure or whatever. But the other way of doing is using robots or tech based solutions which automatically cleans module and with minimal manpower in interference, so that the power system or cables are not getting disturbed. The other important area that is being deployed in power system is remote inspection of transmission lines. So as you know that power transmission lines are a very high voltage transmission system, and it is very important to keep those transmission system up and live, because that's directly linked with the grid security and the ensuring energy requirements of the region. Therefore, there is a requirement to ensure monitoring of the transmission lines, whether there is any fault, or what we call preventive maintenance practices, right? So we need to see and evaluate that in the transmission lines that you see, are the cables working fine? Is the insulator or the other elements of the transmission system are working fine or not? So camera and drones are used to scan the transmission line remotely from the control center itself, and wherever it feels that a particular system is required to be replaced as a part of preventive maintenance, that will be done. So there are a lot of areas where these tech based and AI based solutions are deployed. In power distribution network also, they are using a lot of AI based solution in terms of getting data from smart meters. For example, customer like you who are using EVs. So I as a distribution utility or a power or a load serving entity, I need to track your consumption pattern. That she will most likely use EVs between these hours. He will use to charge EV between these hours.
How will you know I'm charging an EV at that time? Because of the load increase suddenly, that I'm because I mean the companies would just track the kilowatt hour consumption, right? But how
Yes.
will you know that I'm charging an EV versus I'm maybe using a dishwasher or something else, or maybe running my AC?
See, as you mentioned, mostly a typical household will have a certain type of appliances which does not use much of an energy. For example, you only just mentioned that almost two-third of your power bills is coming from electric vehicle, right? so
Uh,
so
half, right?
half
Uh,
half of that.
Yeah, 50%. It's like doubled. So I'm
Yeah,
using 600 kilowatt hours without DV, and then 600. Like I can see it on my app. So if I go on my app, I can see the consumption. So I see
mm,
that it's around 600 something kilowatt hour, and I see that my total bill is twice of that, the
yeah.
consumption. That's
So
for
as a distribution licensee, how I will know that you are charging EV is very simple. If your connected load or contract demand is, let's say, 50 kilowatt, and your EV, I believe you are making a lot of good money, so you would be having a big car, and your battery would definitely be requiring not less than 40 kilowatt of power requirement. So if a consumer is having 50 kilowatt of contract demand, and he is all of a sudden, his real time consumption is touching 45 or 50 kilowatt, it clearly means that he's using EV. Otherwise, if even if you use all the appliances together, you will not cross
okay,
10 or 15 kilowatt, right?
makes
So,
sense.
so therefore, it is very easy to identify when you are charging EV, because the load of EV is of the order 20 30 kilowatt for a fast charger. For a slow charger, obviously, the load requirement would be 7 kilowatt. But still, it is very much identifiable, because if you combine with all other appliances, it would be very easily identifiable that when you are charging EV. So they have a lot of smart meter data that flows into the load serving entities, and they track the consumer behavior pattern, right? When your load curve is going to go up and down, and based on that, I will plan my resource at the back end, that is generating stations at the back end, and I will do my resource planning. I will do my power purchase planning in a manner that, as a load serving entity, I procure the most competitive power from different sources, including wholesale market, and I reduce the supply tariff for my retail consumers, so that I'm a competitive load serving entity. So, in the entire power system, right from using variable renewable generation, right from giving consumers more power to install solar rooftop and manage their own complex energy requirement and selling to the grid, and from using a lot of regulatory and policy stuffs, and then from load serving entities tracking consumer behavior and doing power procurement planning and optimization activities. So everywhere AI and tech-based solutions are required, and it is going to go up only, because as we transition to more and more decentralized and renewable-based transition of the power system. In fact, not only power system. If you see, you yourself, we have been talking about EVs, right? So what is EV? It is actually shifting the demand from a different sector, a petroleum sector, to power sector. So within the entire energy basket, there is a change in energy mix itself. So in the energy mix, the portion of energy which was met by petroleum products will be met by electricity, right?
Yeah.
So as we transition more from both in terms of change in energy mix towards electricity, and within the electricity, you are transitioning from fossil to non-fossil or cleaner sources of energy production. The entire transition will require a lot of tech-based solutions, smart solutions, to ensure real-time operation of the grid, and to help consumers make optimized decision making, both in terms of economics and in terms of environment. They should have a right to choose what kind of energy they are willing to use for their daily needs, so that they address both the economic part of it and also the environmental part of that, as a responsible citizen. So it is very much there, and we believe that going forward, AIML and ChatGPT's type of tech based disruptions would indeed help our sector, and will help the sector to decarbonize and meet the Paris Agreement goals.
Yes. I think the most interesting use case that you mentioned was about having like a chat GPT solution which understands all the power regulation. And I think, uh, by regulation, just adding to it, and I know you would know more about it, but I think power sector is a highly regulated sector. So there are so many regulations from government that you have to follow a lot of guidelines, right? And there's so many documents and acts, power acts or something, that are there that every company has to comply with. And for that you have like specific like group of professionals who kind of take care of that, right? For to kind of advise a company based on regulation what they should be doing or not. So you're saying that there will be a chatbot like a chat GPT, like a language model, which has read through all the regulation documents. And if I want to set up a power sector, plant, I can just ask that chatbot that, hey, I want to set up a plant. What are the things that I need to be, aware of? And that chatbot, because it's aware of all the documents, would guide me through. And then I actually won't be needing those professionals. I mean, I would, but not that much, but I can rely on these chatbots to get information. So technically, I think these are, you know, I mean, from an AI perspective, right? I can uh, definitely make, I think it makes sense because there's a different branch in AI, which is called information retrieval. So information retrieval means I am a consumer and there is a huge data set somewhere, and I want to retrieve information based on my requirement, right? That's what, and the use cases for information retrieval are search engines, right? If I want to search something, I want to get some information, right? So, but search engines are more transactional. I write something and it gives me some links, and that's it. That's the end of the transaction, right? But with the Chat GPT kind of a solution, I can have more like a human like conversation, right? It's not just searching the documents, it's actually explaining it to me in a way I understand. It can explain like let's say I'm a person who is not very much aware of English. I might be good at say Marathi or Malayali language, and I'm asking question in a different language. The chatbot can still go and understand the content and respond back to me in Malayali or Marathi, but it's still understanding the content, right? The regulatory documents and everything. So this can be a very, definitely a huge game changer, right? Especially from a regulation perspective.
Well said, Shield, and truly, appreciate your efforts in terms of, bringing this important element in the discussion. And it's very important that we use more and more tech-based solutions, not only because it is actually need of the hour, but at the same time, how we can empower consumers. The way traditionally we have seen that the power sector, the consumers have little choice, both in terms of what kind of energy you are willing to consume, and how you are willing to consume. So now with this kind of disruptions in terms of rooftop solar and distributed generation, it is very important that tech-based solutions are fully harnessed, and we use these technologies in a manner that empowers the consumers in their decision making in terms of kind of energy that they want to use, and also design more and more solutions. And the other important element that we can also appreciate is that there is an increasing requirement of trade of electricity, and currently what I'm seeing is that in globally a lot of electricity is being traded in competitively in the wholesale market or at power exchange. So similarly, the way we trade stocks in stock exchanges, the power is traded for viewers who doesn't know about power trading. So electricity as a product is also traded in power exchanges. So it means that, let's say, there are various element to it. The buyer and seller can submit their bids, and the algorithm or the exchange technology platform will discover the price at which the power should be purchased or sold. So that kind of tech-based solutions, which actually makes electricity as a trading commodity, is very important, and more integration with the wholesale market is done uh, for the consumers, prosumers, and clubbing the retail level market participants, aggregating those market participants, and facilitating these participants to participate in the wholesale market. More and more AI based solution would be required, right? And the consumer can really feel that they are using most of their capabilities in terms of decarbonizing the grid, and in terms of using the most economically available power from across the country or across across the regional connected market. So all these integration aspect of the prosumers, aggregation of the prosumers in creating local energy market, and also facilitating integration of that local energy market with the central wholesale market will be requiring a lot of AI and tech based interventions. And this is just the beginning, and I believe that over next 10 years the power systems and power sector as a whole is going to go tremendous amount of changes or reforms or upgradations in terms of tech-based interventions, and therefore we need a lot of such solutions. And thanks, Shil, and look forward to people like you who have huge expertise in AIML based solutions, and you have developed a lot of good insights, and you're really keen to do something for the power system professionals to solve their life and make it easier for integration of renewable energy. We would be more than happy to see what kind of solutions we can design to make these transitions smoother and faster.
Nice. Yeah. I mean, definitely, it has been a really insightful conversation for me, Vishu. Look, before we like kind of wrap it up, I just have a couple of questions. I wanted to bring one more thing that Vishu, I remember like when we started a journey, a professional journey together. Uh, I I know that you have been a very passionate guy, and you were so passionate that you would sleep in the office. Why was it so? Yeah, you were
No,
so
actually,
would sleep in the office and never go back home.
so actually, our office and so-called engineers hostel used to be in the same building, in the same premise. So yeah, that make me like we were very advanced in terms of work from home concept. So I think during that time itself we envisaged that tomorrow the work from home culture is going to grow up. So incidentally, my residence was there in the same building, and it hardly took me a few seconds to go from office to home, and so-called home to office. So that was the thing, and it was very interesting journey of power sector. And we have seen the evolution both in terms of a project guy to I have been someone who has even seen the land acquisition related activities. You yourself have been involved in a lot of it's quite laughable when we talk about the activities that we have done, especially in terms of land acquisition, dealing with public in terms of creating awareness about the development and power sector and all.
If you remember, health camps, health camps.
Health camps and so many activities, CSR activities, what we did initially in the
Yes.
beginning of our career. And it really gave us an opportunity to interact with the end community, right?
Yeah,
And
like when we look back, right? Like I think even though it was laughable at that time, that what am I doing? I'm just coloring some map with just different color versus going to a remote location and conducting a health camp. But today, when I look back, right, those kind of things are also learnings, right? It's not always like you
yes,
will learn
yes, yes,
about technology. It's about human to human interaction, reaching out to people in that part of the world where they are like there's like digitally dark zones in a society where people are not very much aware of what's going on, right? Or
mm,
they don't have even basic electricity, so going out to that place and then talking to them and getting to know about that also gives us another perspective of life, right? uh, so yeah, I mean it was interesting, but I mean that was one funny thing that I reminded, and it kind of brought a lot of memories for me because your room in that office used to be a very big thing for all of us. Like even if you remember, like we would go and take a nap sometimes in your room. So it
yeah,
was very interesting. So yeah,
yeah,
I mean.
and,
Uh, since we are already at this point, right? What do you think AI is at this particular moment right now? Do you think AI is going to take over the world, or is it going to have consciousness someday? And what do you think of AI as an end user? And is it like as Elon Musk says, like, is it like going to be disruptive, or it's going to completely you know overpower humanity or something? What What is your take about it?
So honestly, Sheila, I don't think that it will overpower humanity, because at the end we must appreciate that the humans themselves have created this AI. So it should not be seen as a threatening element. Rather than, I see that as an enabling element. For me, as a power sector professional, if I talk about from power sector perspective, I see that we need a lot of solutions based on AI, which helps in optimization and decision making element in terms of how we integrate the complex entities of power system. As I mentioned, that every damn thing in the power sector is now evolving. Whether you talk about consumers who are charging electric vehicles, who are using cooking devices from the electrical energy, uh, to the way we generate power, the way systems are evolving. Type of, you are also aware that there is a concept called vehicle to grid. So, for example, when you are using a Tesla car and you are not requiring a lot of battery energy, and there's battery energy stored in your car, you can even sell that stored energy to the grid, and you can make money, and you can make huge money. For example, let's say in the evening peak, when the grid has a lot of load, right? And the power is not available for the distribution company to source from. So as a Tesla car owner, you can sell that energy and you can make money.
So basically,
So
using my car as a battery and then storing the energy and then.
yes, yes, we call it vehicle to grid, V2G model. So these are just examples, and the reason why I brought it up is to answer and give you a better feel that, see, AI, ML, or any tech based solution is actually the enabler that we need, because now we are dealing with a much more complex power system. We are dealing with so many disruptions and innovations in terms of producing power and in terms of consuming power. And therefore, to solve this complex system, both with the perspective of maintaining the grid operation in a secure and reliable manner, at the same time giving consumer a choice to procure the type of power they need and the cost at which they need. So all these broader level aspect can be solved using tech based interventions. And therefore, I strongly believe that going forward, these would be enablers for us to decarbonize power system. And as I mentioned, the larger objective, we should not forget, whether we are a power professional or a non-power professional, that the climate change is a real threat. And we are all seeing that climate change is for real. And we must do whatever we can, even the small support from everyone's end, in terms of transitioning from fossil to EVs, doing plantations, using energy judiciously, saving energy, using energy efficient systems, responding to incentives like time of day tariff, so that you use higher consuming appliances when the solar generation is higher. So all these, consumer awareness and consumer empowerment needs to be done. And technology solutions, AI based applications will help us a lot in terms of getting these ambitions and targets achieved. And therefore, for the climate goals, we all must appreciate that tech based solutions would be the key enabler.
Awesome. Yeah, definitely, right. Very well explained, Vishu. I really, thank you for taking time out for, having this conversation with me. I know you're an expert and a very busy person, but it has been a really interesting conversation. I've learned so much, and I've been learning a lot from you in the past, 1 decade about power sector. So I hope this, the podcast also, can become like a medium for other people to also learn about power sector, also get passionate about it. Because today when we think about technology, everybody thinks about like coding and AI and all those things, but there is the whole world of power sector, which is as interesting as any other field, and there are very passionate people like you guys working and making all those changes, bringing all the changes and revolutionizing this field. So it's been very enlightening for me, and I hope it is enlightening for everyone who's watching this podcast. So thank you, Vishu, for joining us here, and I wish you all the best in your future endeavors. And I hope we have more such podcasts in future.
Sure, sure, she'll definitely. And once again, thanks so much for bringing this important discussion on the table, and for the viewers and those who want to understand the use cases of AIML in the power systems. And as you mentioned, it's very very important, and people like you definitely will help us in designing some solutions, designing some kind of decision making tools. I would rather call it using AIML based applications so that the power system and power sector transition is facilitated. And once again, very very thanks, and a lot of credit goes to you in terms of organizing this particular podcast. And I totally appreciate and would like to have more such discussions on see, this era is all about using technology to solve the problems and meet the climate goals. So the broad line objective that you have set is that how I can, as a power sector guy, I can use your products and solutions to solve my problem and address energy security as well as climate change objective. And therefore I really thank you for this bringing this important element up for the discussion. And surely we will organize much more, many more sessions like this.
Yep. Awesome. Thank you so much, Vishu, and thank you everyone who are watching this podcast. If you like this content, definitely like, share, and subscribe. And until then, I'll see you guys again in our next one. Thank you.
Thank you.